Okay, hello everyone. Hope you guys are still doing well. So starting today, we're gonna move into our last part of the last unit. So we've been talking about rational functions, and so far we've done operations, so adding, subtracting, multiplying, and dividing with rational expressions. And then the past couple of days, we did how to solve rational equations. And then the last part, we'll talk about how we can graph these rational functions. Okay, we probably won't get through all of graphing, but we'll try to get through as much of it as we can. So let's go ahead and get into it. So here is the parent function of the rational function, f of x equals 1 over x. Now this looks pretty simple, but graphing it is actually a little bit complicated. So we'll see how we can do that. But the parent function is the rational function. Okay, and as with all families of functions, we have our transformation table, and then our starting value in this case is going to be -2, -1, 1, and 2. Okay, you might be wondering, why do we not use 0? But I think the answer to that will be pretty obvious in a second. So those are our x values. So then how do we find the y values? Well, we just go ahead and plug it into our equation. So when x is -2, y will be 1 over -2. So we can leave it like that, or write that as -0.5. When x is -1, 1 over -1 is -1. When x is 1, y is 1. When x is 2, 1 over 2 is 0.5. Okay, so now why don't we use 0 as an x value? Well, if we were to use 0, then our y will be 1 over 0, which, as we know, we can't divide by 0, right? Because it's undefined. So that's the reason why we don't use y equals, or why we don't use x equals 0. So now let's go ahead and graph our points. So I have -2, -0.5, -1, -1, and then 1, 1, and then 2, 0.5. Okay, so far we don't really see, too much. It's just kind of 4 random points. We don't really see what the graph will look like just yet. Now, the reason why I said rational functions are hard to graph is because we're going to have both horizontal and vertical asymptotes. Okay, so remember when we did exponential functions, so equations like y equals 3 to the x, these types of functions have a horizontal asymptote. Okay, and then our last unit was log functions. So if I have a function like log base 3 of x, these types of functions have vertical asymptotes. Okay, so now we're kind of putting these all together. We have rational functions, and we're going to have both horizontal and vertical asymptotes. Let's start with seeing what the horizontal asymptote is going to be. So to help us do that, let's go ahead and pick a few more points for x. So let's say I pick x as 10. Okay, so then y will be 1 over 10, which is going to be 0.1. So let's go ahead and graph that. When x is 10, y is 0.1. So that's going to be right about there. Okay, so as we see, when x gets really, really big, our y value is going to get really, really small, but it's still going to be positive. Okay, so then we know this part of the graph will look something like this. Okay, and then what happens if we pick a really, really small x value, like -10? Well, the y will be 1 over -10, which will be -0.1. So when x is -10, y will be -0.1, so that's about there. And then same thing, as x gets really, really small, our y value will get really, really close to 0, just like that. Okay, so now I think we all see what the horizontal asymptote is going to be, and that's going to be right down the middle here, the x-axis. And let's go ahead and graph that using a dotted line, and then that's going to be the line y equals 0. Okay, but that's actually not it for the graph. Let's also see what happens if we pick x values that are pretty small. So let's say we pick x is 0.1. Okay, so now the y will be 1 over 0.1, and you can use a calculator to verify this. This is going to be 10. Okay, so when x is 0.1, our y is 10. So that's all the way up here. Okay, so when x gets really, really small, our y actually gets pretty big. So then it's going to look something like this. Here we go. And then similarly, when x is negative 0.1, y will be 1 over negative 0.1, which will be negative 10. So same thing when x gets really, really small, and it's negative, then y will be pretty small. So it's be down here, and our graph will look something like this. Okay, so now we see where the vertical asymptote is as well. It's gonna be the y-axis, so this dotted line right over here, and that's gonna be the line x equals 0. Okay, so now you see what I mean when I say that these functions are kind of difficult to graph. Okay, it's because there's kind of two parts to the graph, right? We have a purple part right over here in the first quadrant, so right over here, and then we have it in the third quadrant down here. So it's kind of two pieces to the graph, and there are also two asymptotes. Okay, so let's go ahead and find the rest of our key features. What's my domain? Well, so for these, I think it's easiest to write it this way. So for domain, I think our domain is all the possible x values, and it's going to be all real numbers except 0, it looks like. Right, so x can be all real numbers. So x can be, negative 1, x can be negative 1, negative 2, all the way to negative infinity. And then it can be, 1, 2, 3, all the way to positive infinity. The only value that x cannot be is our asymptote, which is 0. Okay, so there's my domain, all real numbers, except x cannot be 0. And then for our range, it's going to be pretty similar. It will be all real numbers, except y cannot be 0. Okay, so range is the y values. So y can be any positive number going up. Y can be any negative number going down. But the only y value that's not on the graph is y equals 0. So x can be all real numbers except 0. Same thing with y. All real numbers except 0. What's my end behavior? Well, as x gets to infinity, meaning as x gets bigger and bigger, so I'm going to the right, what happens to my y value? Well, y is getting closer and closer to 0. As x goes to negative infinity, as I'm going left, our y value is getting closer and closer to 0 also. So 0 here as well. Okay, so that's how we can graph the parent function of the rational function. And then as we've done with all other types of functions, we're going to see some transformations. Okay, so now let's go ahead and look at this one. 1 over x plus 3 minus 2. Okay, so by now I think we're pretty familiar with these. So the x plus 3, the plus 3 goes with the x, so that's going to shift it left 3. And then the negative 2 on the outside will be down 2. And then let's go ahead and start with our same points, negative 2, negative 1, 1, 2. And then these are our y values as we just saw above. So left 3 means I'm going to go over here with the x. So here we go, negative 1. And then down 2 is with the y's, negative 2.5, negative 3, negative 1, and negative 1.5. Okay, so let's go ahead and graph these points. So negative 5, negative 2.5, right over here, negative 4, negative 3, negative 2, negative 1, and then negative 1, negative 1.5. Okay, as with the other functions that we graph, the ones that had asymptotes, it's always easiest to graph your asymptote first before you join the rest of the graph. Okay, so let's see. Let's start with the horizontal asymptote. So normally it will be right over here, the line y equals 0. Now in this case, my graph is shifted to the left 3. So if I shift this green line to the left by 3, that doesn't really change it. But if I shift it down 2, that's gonna affect my horizontal asymptote. So instead of being at y equals 0, it's gonna be y equals negative 2 because we're shifting it down by 2. And then same thing with a vertical asymptote. Without any shifts, it will be this line down the middle, the y-axis. I'm shifting to the left 3, so then that's gonna make it go over here, left 3. And then I'm shifting it down 2, but that doesn't change our vertical asymptote. So then our new vertical asymptote will be x equals negative 3. And now we can use the asymptotes to help us join the rest of our graph. Okay, so Once again, it's going to be the similar shape as the one we just drew above. It's going to look something like this. And then similarly down here as well. Okay, again, it's very easy to draw once you have the asymptotes in because they kind of guide us to the rest of the graph. All right, key features, domain and range. So domain, x can be all real numbers, except in this case, x cannot be -3, right? That's where our asymptote is, but x can be any other number. And then our range, all real numbers, except y cannot be -2. Once again, that's where our horizontal asymptote is at y equals -2. And then end behavior, as x gets really, really big, y approaches what value? Well, that's -2. Same thing as x goes to -infinity, y is going to approach -2 as well. -2, -2. Okay, so that's horizontal and vertical shifts as we've seen plenty of times. And then now let's look at something where there's going to be a reflection as well as a vertical stretch. So we have -2 over x minus 4. First of all, the x minus 4 tells us we're going 4 to the right. Okay, now we have a negative sign in front, right? So the negative sign on the outside tells us it's going to be a reflection over the x-axis. If this negative sign was down here, if it was with the x, then it will be a reflection over the y-axis, but we're not going to worry about that for this unit. So reflection over the x-axis. And then what about the 2 up top there? Well, this is a 2, so that's bigger than 1, so that tells us it's a vertical stretch. If it was less than 1, like 1/2, then it will be a vertical shrink. But I don't think we're going to worry too much about that either. We're just going to look at vertical stretches. So let's go ahead and graph it, starting with the same starting values, -1, 1.5. Okay, 4 to the right, that's going to be with the x, 4 to the right. And then it will be 2, 3, 5, 6. And then the -2, the vertical stretch, will be with the y's, as is the case with all the other functions we've done. So that's going to be 1, that's 2, that's -2, that's -1. And then let's graph the outside values. So 2, 1, 3, 2 is there, and 5, -2, 1, 2, 3, 4, 5, -2, 6, -1 is there. And then again, it's easiest if we graph the asymptotes first. So let's look at the horizontal asymptote first. Normally it's this line right over here at y equals 0. Now we're shifting to the right 4, but that doesn't really affect our horizontal asymptote. So, and then there's no vertical shift. There's no shift up and down. So then our asymptote will stay the same at y equals 0. And then vertical asymptotes, normally it will be at this line down here. But because we're shifting 4 to the right, we're going to go 4 to the right. So it will be right over here. So that's going to be x equals 4. And then again, as we see, once you have the asymptotes drawing, the rest of it is, fairly straightforward to drawing. You don't have to be perfect, but just kind of do your best here and drawing our shape. There we go. And then let's go ahead and verify this with the other graphs that we've done so far. Because this one is reflected, it's going to be in the 2 other quadrants. It's going to be in this top left and then bottom right, as opposed to the ones we did before. And then shift it to the right 4, and that looks good as well. Okay, domain range. So here, x can be all real numbers except 4, it looks like. And then range, I think all real numbers except y cannot beat 0. And behavior, as x gets really, really big or really, really small, I think our y value is approaching 0. Here and here. Okay, so that's pretty much it, actually, in terms of graphing with the parent function. Once again, slightly trickier than the other functions we've done because there's 2 asymptotes and there's kind of 2 pieces to the graph. Okay, so I'm going to walk through one more with you guys. But if you like, you can actually pause the video and try this yourself, and then we'll talk about this together. Okay, so let's first look at the transformations. We have right 6, up 3. Once again, reflection over x-axis. And then the 4 tells us, once again, it's a vertical stretch. Okay, so let's go ahead and put in our starting points. These will always be the same each time. And then to the right 6 goes with the x. Okay, hopefully we are pretty good with these at this point. 7, 8. And then always the vertical stretch comes first before we go up or down. So times -4 first, so that's 2, 4, -4, -2 it looks like. And then going up 3, that's 5, that's 7, -1, and 1 it looks like. So let's graph these. 4, 5, that's gonna be about there. 5, 7 is there. 7, -1, that's down here. And then 8, 1 is there. All right, once again, let's graph our asymptotes first. Horizontal asymptote, because we're shifting up 3, we're gonna go up 3. So there's our asymptote, horizontal asymptote, y equals 3. Vertical asymptote, I'm going 6 to the right. So then I'm gonna go over here to the right 6, x equals 6. And then here we go, let's go ahead and join the rest of our graph. Once again, with the asymptote, it's gonna help us a lot when we graph these. Domain and range. Domain, x can be all real numbers except 6, and y can be all real numbers except 1, 2, 3. Okay, and then behavior, as x gets really big, y approaches 3, and same thing with x gets really small. Okay, so that is it in terms of graphing with the parent function for the rational function. Please go ahead and finish the rest of these. There's, I think, 5 more graphs, but the idea is exactly the same as the ones we've just done so far. Remember to start with your starting points, which are these points right over here, and then putting the transformations as we've done, the same way we've done all year, and then make sure you graph the asymptotes first, because that's going to help you a lot. Okay, so as always, make sure you take notes as you watch this. Please try the rest of this handout. I think there's 5 more graphs. If you have any questions, please do let me know. Other than that, thank you for all the hard work you've been putting in, and I'll see you guys next time.